Good day, everybody. We're looking for an integer between 1400 and 1500 that's sort of related to the modulus here that will be a solution to this seventh degree congruence. Now, they may look rather difficult. You know, seventh degree polynomials are certainly hard to solve, right? So what about the congruence? Well, it turns out there's a result that makes the problem really quite straightforward. Certainly, just by definition, b is congruent to 0 mod b. That literally says b minus 0 is divisible by b, so it's rather trivial. But it is, in the mod world, b is the same as 0. All right, now, so this result follows. Now, this is a proof that's unnecessary, but this result also proves it. If you don't trust this statement right here, just substituting 0 in and getting 1 out, this is also a proof for all of these two terms are both congruent to 0 as well. And you get that b minus 1, which is serving as the modulus, quantity squared is congruent to 1. Now that simplifies things immensely as far as calculating solutions to these congruences, because notice that if we choose b equals to 19, or b is equal to 719, excuse me, what we get right here, this implies that 718 squared is congruent to 1. So you see this huge number, which is useful because it's a power of 2. It's congruent to 1 mod 719. Okay, so that comes a tremendous service, because what we can do is use the laws of exponents to get a lot of occurrences of 718 squared, which we know is 1. You see, there's 718 squared, there's 718 squared, and these are just laws of exponents primarily that are motivating all of this. Okay, or not motivating, but they're making things simpler. Okay, and you guys, just in case you're not seeing the laws of exponents here, this is 718 to the 7th power, right? Well, 718 squared, which we know is 1 mod 719, that's 718 squared cubed is 718 to the 6th times 718 to the 1st is 718 to the 7th. And we use similar reasoning for the remaining terms all the way out. Here we just have 718 squared, which is easy pickings. Now watch this. Again, 718 squared is congruent to 1 mod 719. We don't even know how to expand. We don't have to know how to pronounce 718 squared. You know, all that's important to us right here is that it's the same thing as 1 modulo 719. So you see right here, what we're left with here would be congruent to 718. See, folks, 718 is all that's left standing, because 718 squared is 1. And right here, this is just plus 1. Again, y'all notice I switched from equality to congruence. Okay, now in a similar fashion right here, I'm trying to keep it lined up. Okay. And again, folks, I am just using this to death. 718 squared congruent to 1. Okay, and then we have plus 718 here. And then finally plus 1 right here. And this is a congruence. Now, another useful thing to notice at this stage, we're trying to prove that this is all equal to 0, right? Well, does that mean we have to add up 718 3 times and see if it's all divisible by? You can tell by looking at it that this would be congruent to 0, by the way, right, folks? Because this would be 3 times 718 plus. In fact, we can do that if you want. There's two ways to do it. You can think of that 718 is also congruent to -1. But y'all, you could write this as 3 times 718 plus 1, which is a multiple of 719, right? So that's the straightforward way to do it. But if you want to keep it in terms of modular arithmetic, 718 is congruent to -1, right? 718 minus -1 is 719, right? Okay, so we're sticking to congruent, but we could have done it directly, folks. I just want you to know. Somebody will say that in the comments. And yeah, you can do it directly, or you can just stick to modular arithmetic. But this will be plus 1, and then this will be plus minus, or this is minus 1 here, plus 1. And it looks like we have as many minus 1s as plus 1s, right? 1, 2, 3 minus 1s, then 1, 2, 3 plus 1s. So what's that? Can we do that in our head? Do we need a calculator? No, that's 0, right? Okay, so that's for 718, and that's what we're trying to find, folks. We started with this expression right here. We have equality and then congruence, and it is congruent to 0. Now, that's not the answer, but so we know that we have 718 as a solution, right? But also notice that 718 plus any multiple of 719 is also a solution. And that follows immediately from the fact that 719 is just 0 modulo 719, right? Yeah, so n is an integer. N is some integer here. Folks, so notice if we choose n equals 1 right here, if we take n to be 1, we would get, let me just write n equals 1 right here. We're seeking a number in this range. So that'll be 718 plus 719. And that sums up to 1437, which is a number between 1400 and 1500. Okay. Guys, if those of you familiar with congruence arithmetic, anytime you found a solution, you can add any multiple of the modulus that you want. And right here, n would just be a proud member of z. The solution we found corresponded to z equals 0. All right, but we're just spice this up just slightly. We were seeking a number outside of what they call a reduced residue class, I think, or something like that. But in any event, this is the answer I was looking for in this problem. And this little lemma made it a very doable problem. Think about how you might have proceeded if this didn't come to you. This is pretty easy after the fact, but to think about it, maybe it's a little bit of a needle in a haystack. I think maybe you could use quadratic reciprocity to solve this, probably so. Search around for an answer, And also, I don't know if 718 is a unique answer in the reduced residue class. Some of you guys may explore that. I don't know if it is or not. I think 719 is, I don't know if 719 is even prime or not. But in any event, it doesn't matter that 719 is prime as far as the way the solution to this problem went. Okay, so that's our solution. Thanks for viewing.